Let me open this serial communication interface module here. Data sheet. Instruction set summary, and then serial communication interface. Timer on module, IO port. Serial communication. Yeah. Addressable, universal, synchronous, asynchronous, receivers on transmitter. This is what it is. USART. Right. Asynchronous. We know what is asynchronous. Asynchronous means the receiver. Let's say a transmitter is commanding the receiver for something. The receiver can take some time to respond. It is of arbitrary length. There is no mandatory response required immediately. See, the transmitter is shifting a bit to the receiver. Receiver can take its own time to respond back. That is what called as asynchronous communication. Right now. So that one is, we are going to implement that communication now. Universal synchronous asynchronous receiver transmitter module is one of the two serial IO module. USART is also known as serial communication interface, or SCI. USART can be configured as full duplex asynchronous system that can communicate with peripheral devices such as CRT terminal and personal computers, or it can be configured as an off duplex synchronous system that can communicate with peripheral devices such as a EAD, analog to digital converter, digital to analog converter, and serial EEPROMs. Right now, so like that, off duplex synchronous and full duplex synchronous. I believe we are going to do a full duplex. USART can be configured in following modes: asynchronous, synchronous master, synchronous slave. Right, these are the different ways we can use USART. We will use the USART in the first asynchronous full duplex. There is a bit in the register called RCSTA. RCSTA, right? Called S-Pen, serial port enable. Actually, the meaning of that acronym is serial port enable. And the bits Txsta 6 and 7 have to be set, meaning we have to set those bits to 1 in order to configure pins RC6 TX bar clock and RC7 RX bar DT as universal synchronous asynchronous receiver transmitter. The very first step is we have to enable the serial port. For that, the bit that we have to set is SPN, serial port enable. That bit should be set to 1. Right? After that, after setting that bit, we have to set 2 more bits. What are those? Port to C bit 6 and bit 7, as one should be configured as output pin, meaning the TX pin should be configured as output pin, and RC7 RX pin should be configured as input pin. Does that make sense? So we have to do these 3 configuration first. Only then we can do serial communication, serial port communication. Right now, USART module also has a multiprocessor communication capability using 9-bit address detection. That is different topic. We are not going to do that now. So we are going to explore every registers that is related with serial port communication, right? So the first register is Txsta, transmit status and control register. In that, actually the bit start from here, bit naught, and this is bit 7. So in bit 7 we have CSRC, clock source select bit. What it really means, I already told. Serial communication interface is a peripheral. CAN is a peripheral. SPI is a peripheral. I2C is a peripheral. These are circuitries, logic circuitries. These circuitries require clock to work. We have to supply some clock. If you don't supply the clock, that circuitry will not work. Got it now? From where we are going to get that clock? I also told the synchronous communication require a clock signal to work with. Only the asynchronous doesn't require a clock for communication purpose. We are going that this bit will select clock source. Are you going to use that as in a master mode or slave mode? If it is a slave mode, clock will come from external. So they will get it from outside. There will be a clock circuitry that will supply the clock. In master mode, the internal microcontroller itself, the clock will be derived from the oscillator that they are connected. If I connected 20 megahertz oscillator means from that they will derive, right, using a register called BRG, right? That we will study later. If it is an asynchronous one, this bit is don't care. Even if you have any value there, that is not considered. So as far as we are going to do asynchronous communication, we no need to bother about the synchronous mode. We no need to bother about this particular bit at all. Understood? Then 9-bit transmission enable. Actually, usually we used to exchange 8 bits of data in SCI. When you want to do a 9-bit one, you can set this bit TX 9-bit. If you set this particular bit to 1, select 9-bit transmission. When you set that to 0, it is 8-bit transmission. So as we are going to do a 8-bit communication, we can keep this bit to 0. This is also 0. This is also 0. And then TX enable. Whether the transmitter is enabled or not, that is decided by this particular bit. When you set that bit to 1, it is enabled. When you set that to 0, it is disabled. You can enable or disable your transmission using this bit. Got it? Then a sync bit. When you set this bit to 1, it is in synchronous mode. When you set this bit to 0, it is asynchronous mode. So obviously we will set this bit to 0 because we are going to work with asynchronous. Bit 3 is unimplemented, and then BRG H, baud rate high selection bit, right? Usually as we are using this 20 megahertz clock oscillator, we will set this baud rate value to baud rate high speed baud rate. Asynchronous mode, we will set this value to 1, baud rate high. When it comes to synchronous mode, as it is going to use a clocks to exchange, this particular bit is don't care in synchronous mode. In case of asynchronous mode, we use them. When we set that to 0, low speed. When we set that to 1, it is high speed. right? Then transmit shift register status bit. I told one thing about this serial communication. When they want to transmit something, they will put that in a register called transmit register. From that register, the bits will be shifted serially one by one. That is what I told right now. We discussed that during the scan introduction, something like that. Right? So when they shift this, when they shift that transmit register content one by one, right? If that register is empty, this particular bit will be set to 1. Why we require it? To push a next word. If we don't have a flag whether the all bits are shifted or not, we do not know whether the previously written value in the shift register is completely shifted. We will overwrite it. So that this TRMT bit helps us to decide whether the TSR is empty or TSR is full. As long as there is a bit remains for shifting, that will be, this particular bit will be in 0 state. Moment that is empty, that bit will become 1. Understood? Come on.
Yes, sir.
Amir, Vikash.
Yes, sir. Understood.
Yeah.
Then TX90, ninth bit of transmitted data can be a parity bit. This is like a 9-bit transmission. In that they use, we have only in RC register or receive register, transmit register, we can hold only 8 bits. When we do a 9-bit communication, we have to provide some location to store that 9th bit, right? That is stored here. That is what it is.